We're going to review solving polynomial equations. So whenever you have a polynomial equation, you have a polynomial on one side, you may have a polynomial or a number on the other side. Your goal is always going to be move any variables and numbers over to one side, factor the polynomial side, and have this side equal to 0. Anytime you get a factored polynomial equal to 0, you can easily solve these equations. So your goal is to get your equation to look something like this. I have two factors multiplied together and they equal 0. From here, all you do is set each factor equal to 0. So my one factor is x plus 5, so I set that equal to 0. My other factor is x minus 4. Set that equal to 0, and now you solve each of these equations. To solve this equation, I would subtract 5 from both sides, so x equals negative 5. To solve this equation, I would add 4 to both sides, and I would get x equals 4. So these are my two solutions to this polynomial equation. Let's look at one a little more complicated. If I have 64p squared minus 16p plus 1 equals 0. The first thing I'm going to do is make sure that my polynomial is equal to 0, and it is. So now I'm going to factor this side of my polynomial. You may multiply 64 and 1, look for factors of 64 that have a sum of negative 16. I'm going to check to see if this is a perfect square trinomial first. So 64p squared, well, that is 8p squared, and 1 is 1 squared. So if this is a perfect squared trinomial, this would be my a and this would be my b. So now I need to check my middle term. 8p times 1 is 8p, times negative 2 is negative 16. So I have a perfect squared trinomial that's in the form ax squared minus 2ab, a squared. A squared minus 2ab plus b squared. Since I'm in this form, I can factor this really easily. I know that this is 8p minus 1 squared. Minus. And I'm equal to 0. So I have 8p minus 1 times 8p minus 1 equals 0. So now that I have factored my polynomial, I'm going to set each of my factors equal to 0. In this case, my factors are identical, so I just need to set 1 equal to 0 because they're exactly the same two factors. When I solve this, I'm going to add 1 to both sides. 8p equals 1. I'm going to divide both sides by 8. P equals 1/8. And this is your solution to your equation. You can always double check your answer by substituting in this value into your polynomial and making sure that it equals 0. I'm sure if you were to do that in this case, it would equal 0. We're going to look at one more that is even more slightly complicated, but nothing we can't handle. 8w squared equals 50. So automatically a red flag should go up because we are not equal to 0. First thing I'm going to do is get my equation equal to 0. So I'm going to subtract 50 from both sides. When I do, I'll have 8w squared minus 50 equals 0. Now I'm going to factor this polynomial. I have a binomial, so the first thing I'm going to try to do is factor out a greatest common factor. Here my greatest common factor is 2. So I'm going to factor out 2. I'll have 4w squared minus 25 equals 0. Since I have factored out a number, just a number by itself, no variables involved, I can divide by that number on both sides. and it now goes away. So I have 4w squared minus 25 equals 0. The next thing I notice is I don't have any more common factors other than 1. That's good. That means I took out the greatest common factor. But I do have a square number here, a square number here, and I'm taking their difference. So I have a difference of squares. So I can immediately go 2w plus 5, 2w minus 5, and that equals 0. So now I have two factors being multiplied, and their product is 0. So I'm going to set each of my factors equal to 0 and solve. So these were my two factors. I set them each equal to 0. When I solve this one, I'll end up with negative 5 over 2. When I solve this one, I'll end up with positive 5 over 2. So these are your two solutions to your equation. If you wanted to check your work, you could separately, one at a time, plug each of these values in for w and make sure that your equation equals 50, and I'm sure that it would. And that's how you solve polynomial equations.